Lesson 68, mutually exclusive and inclusive events. First off, if you look at mutually exclusive, means you have two separate events happening, which means they can't happen at the same time. They don't overlap. Dependent events means you have two events that you can have some overlapping data. So let's take a look at some examples here. So the probability of mutually exclusive events says if A and B are mutually exclusive, that means they're two separate events. To find the probability of it, you would take the probability of event A and add it to the probability of event B. What is the probability of rolling either a sum of 6 or a sum of 11 using two different number cubes? So in here, on the right hand side, I have a chart that shows the number cubes, the two of them. We have one on the side and one on top, and then the sum of the rolls. So the blue boxes on the outside are the number cubes. The white boxes with the numbers in there are the sums. So the sum of 6. So if I look at the ones that have sum of 6, I got one here, 2, 3, 4, 5. So I got 5. So 5 out of, and there are 36 here. Because we got 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So 5 out of 36 are sums of 6. Plus sums of 11. Sums of 11, I look here, I get 1, 2, 2 out of 36. 2 out of 36 gives you a sum of 11. If I add them together, I get 7 out of 36. So the probability of rolling either a sum of 6 or a sum of 11 would be 7 out of 36. Next, what is the probability of rolling either a sum of 5 or a sum of 12? So the sum of 5, let's circle those. I have 4 out of the 36 are 5s. Sum of 12, I only have 1, so 1 out of 36. Add them together, I would get 5 out of 36 would be my probability. And we'll just keep our answer as a fraction. Next one, what is the probability of rolling either a sum of 2 or a sum of 10 using two different number cubes? So a sum of 2 is only 1, so that's 1 out of 36 chances of getting a sum of 2. A sum of 10, we'd have 1, 2, 3, so that's 3 out of 36. Add them together gives you 4 out of 36. Reduce would give us 1 out of 9. So you have 1 out of 9 chances of rolling either a sum of 2 or a sum of 10. Probability of inclusive events. So inclusive means you have two different events, but some of them overlap. And so we need to be able to take the overlapping ones out because you can't count them twice. So the formula is find the probability of event A, add the probability of part B, of event B, but then you need to subtract the ones that are in both events. So what is the probability of rolling at least one odd number? So rolling at least one odd number. If I look at that one, that would be all of these, because all of these have at least one odd number. That would be this one, because I have an odd number here. We can use all of these because they're making use of at least one odd. All of these making at least one odd. All of these making at least one odd. And then we got at least one odd number down here because of 3s and here. So the ones that we're not using, I'm going to put a red box around the ones that we're not using. Not using this 4, not using this 6, we're not using this 8, we're not using 10. So I can keep this as red. Not this 8, not this 6, not this 8, not this 10, or not this 12. All the other ones we are using. So the probability of using at least one odd number. So we got 6, 7, 8, 9. So 6, 12, 18. Let me use a different color here. So we got 6, 12, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So 27 out of the 36 gives me an odd number. You use at least one odd number. Plus the sum of 8. So I'm going to use a different color where I get sums of 8s. So that would be 1, 2, 3, 4, 5. So 5 out of the 36, I use an 8. But I need to subtract any of these 8s that are counted in both of them. So I'm going to use a different color. Let's use blue. So this one is used in this column. This 8 is being used in this column because that's an odd. That was using an odd number, and it's a sum of 8. So now we have 2 out of the 36 that were in both lists. So now if I add them together, 27 plus 5 is 32. 32 minus 2 is 30. 30 over 36 divided by 6, 6. You would get an answer of 5, 6. So the probability of getting rolling at least one odd number in a sum of 8 would be 5 out of 6. So that's a very good chance of that happening. Next one was the probability of rolling at least one even number. So if it's one even number, I need to look at this column, this column, this column, this column, this column, and this column. I'm going to put a blue mark where I used at least one odd number, or one even number. I used 1 here, here, here. To get all of these, I used the 2. Here I used a 4. Here I used a 6. And then over here, I used a 2. I used a 4. I used a 6. So let's count all the blue dots I have. So I got up here, I got 6, 12, 18. And I got 19, 20, 21, 22, 23, 24, 25, 26, 27. So 27 out of 36. I used at least one even number, plus the sums of 10. So I'm going to put a red dot where there's sums of 10. 1, 2, 3. So there are 3 sums of 10. So 3 out of 36. And then I'm going to subtract the ones that have both dots, both red and blue. This one has both red and blue. This one both has red and blue. So I need to subtract those two. So 2 out of 36. 27 plus 3 is 30. 30 minus 2 is 28. 28 out of 36. If I divide these by 4/4, I end up with an answer of 7 out of 9. So 7 out of 9 chances I would get either an even number or a sum of 10. Next one. What is probability of rolling at least one even number? So since we've done the even number, we know that there are 27 out of 36. You get at least one even number. Plus the sum of 3. 1, 2, so there's 2 out of 36. Now are any of these using at least one even number? Well, this uses an even number, This one uses an even number. So I subtract 2 out of 36. I end up with 27 out of 36. I divide this by 9/9. I end up with 3/4. So 3 out of the 4 chances you will get an even number or a sum of 3. And a couple application problems. Bryson needs to randomly call 125 people from the state of Wyoming to conduct a short survey. The following data corresponds to estimated values from 2005 describing the state's populace. Bryson assumes that everyone who is employed is younger than 75. How many people can he expect call who are either employed or are 75 years or older? So let's look at how many are employed. Since all of our numbers are in the thousands, I'm just going to look at the first parts of the numbers to make it a little bit easier. So the numbers that are employed, the number of people employed are 291,000 out of your 510,000 people. And those people who are 75 years or older, we have 29,000 who are 75 and older out of the 510,000. If I add them together, 291 plus 29,000 would give us 291 plus 29. This would give us 320,000 out of the 510,000. And from that point, I can simplify that. So let's just, we can already take the, we can divide, actually we can divide 1,000 on both of them. So now we're at 32 over 51. So that would be our probability. And it says that they're going to be calling 125 people. So if I take that times 125 people, so 32 times 125 divided by 51, you get about 78.43, which is about 78 people. So they can expect about 78 people who are either going to be employed or 75 years or older. And the last one, Natalia has music from a variety of different artists on her MP3 player. There are 26 rock artists, 18 pop artists, 19 country singing artists, 10 alternative artists, 7 crossover artists. The music by the crossover artists Natalia chose is on the pop and country charts. If Natalia's music player randomly selects the next artist, what is the probability that the artist will be singing pop or country song? So let's look at the total number of artists. If we add up the total number of artists, we end up with 80, because 26 plus 18 plus 19 plus 10 plus 7 will give us 80. So we have a total of 80 artists. What is be singing pop or country? So pop, there are 18. Plus you got the crossover artist choices on the pop and country chart. So I have to include that in there. So that would be 25 because of 7 plus 18. And then the country, we have 19. 19 plus 7 is 26. And then we have to subtract the ones that are on both of them. So 7 of them are on both of them, so we need to subtract that. So we end up with 25 plus 26, which is 51. 51 minus 7 gives us 44. 44 out of 80. Divide this by 4/4. This would give us 11 out of 20. So the chances that her choosing either pop or a country would be 11 out of 20. That is our lesson today on mutually exclusive and inclusive events.